Hello and welcome. My name is Oxana Mian. I am a postdoctoral trainee at the Health Sciences North Research Institute. Today I will talk about our project titled Early Life Adversity and Frailty. Briefly, frailty can be defined as increased vulnerability to adverse health outcomes from minor stressors. 1.5 million of Canadians are living with frailty, and this represents a significant economic burden on the healthcare system. There is an opinion that frailty is a public health priority, similar to other population-wide disorders. Another key term in our study is early life adversity, or ELA. That is an umbrella term for child maltreatment considered in the context of the entire life course. There is a wealth of research showing that ELA has a negative impact on health extended to the adulthood. However, less is known about ELA and aging, and hence our research questions. We have 3 research questions in our study. Is early life adversity associated with frailty? How are different ELA types associated with frailty? And if the association is significant, whether sex and age moderate this association. In our study, we use data from the Canadian Longitudinal Study on Aging, a national study. Specifically, we use data on the comprehensive cohort that includes more than 30,000 adults. Frailty in our study is measured by Frailty Index based on a deficit accumulation approach developed by scientists Rockwood and Mitnitsky. The Frailty Index is a continuous variable ranging from 0 to 1. We use 9 variables derived for each participant for exposure to ELA, 8 dichotomous variables for single ELA types, and a total ELA load computed as the number of ELA types reported by each participant. Now let's turn to our results. Prevalence of ELA varied across different types, with the physical abuse being the most prevalent at 27% and neglect being the least prevalent. In total, close to 40%, 39% of participants didn't report any ELA type, 28% reported only one ELA, 15% reported 2, and the remaining 18% reported 3 and more ELA types. Prevalence of ELA was higher in females across all ELA types, except physical abuse that was more prevalent among males, and parental death and divorce that were equally prevalent in both sexes. A higher prevalence was found in middle-aged group compared to the older group, except parental death. Frailty Index, our outcome variable. Distribution of the FI was positively skewed. Frailty Index increased with age, as the graph shows, and it was higher in females than males and increased more rapidly in females. Frailty Index was higher for those exposed to all ELA types, particularly for neglect and emotional abuse. It also increased with the number of ELA types. Women had a significantly larger effects of exposure to ELA on Frailty Index, both for single ELA types and for the total ELA at the level of 3 and more ELA types. Interestingly, the sex moderating effect that we showed on the previous slide was more prominent in the older group than in the middle-aged group, and that was true. That pattern was true both for the single ELA types and for the total ELA. Here we show the that relationship, that pattern for single ELAs. So we can see that in the younger group, there wasn't much of difference between increase of frailty index between sexes, but more sex differences are observed in the older group. Younger age group and middle age group are shown in a light blue, tended to exhibit larger effects of ELA on frailty index. We can see it for neglect, emotional abuse and physical abuse, parental deaths. The coefficients were higher for the younger group. Similarly, for total ELA at the level of 3 plus types and 2 plus types, the middle-aged group had a larger effects of ELA exposure on frailty index. And here is the last slide showing that the age moderating effect that we've seen on the previous slide was actually more prominent in men than women. And that pattern applies both to the single ELAs and the total ELA exposure. But here I only show the graphs for total ELA. We see that the coefficients for younger and older groups were not different for females. However, for males, the age differences were present. Though the positive association of frailty index with ELA exposure found in our study was probably expected, our study provided important findings about the association. First of all, it's heterogeneity across ELA types, difference across single ELA types. Second, differences across sex and age groups, and also different thresholds for severity of ELA for significant moderating effects of age and sex. Further research may be needed to interpret our findings. For now, we can suggest, based on the existing literature, that difference across different ELA types in association with frailty may be explained by differences in protective reactions that are triggered by the different ELA types. For example, a direct threat, physical abuse, and adverse events such as divorce of parents can trigger different processes in a child. Age differences can be explained by the cohort effect and by the different historical and social circumstances of the older and younger age groups in our study. It can be that more awareness among young participants about childhood abuse and stronger recall bias and data loss in follow-up in the older group also contributed to the age differences. In terms of sex differences, there are studies showing that biological, psychological, and social pathways from exposure to ELA to health outcomes are different for males and females. In conclusion, early life adversity, as found in our study, is highly prevalent among Canadian adults, and it increases the risk of frailty, with the impact varying across different adversity types, sex, and age groups. Hence, preventative measures targeted at those who have experienced early life adversity of certain types and severity even younger adults may contribute to the improvement of the overall aging trajectory.